The LBT210 soldability tester is easy and safe to use, modular with up to 8 test options, packed with feature-rich software providing full traceability. Test your components, substrates, paste, flux or wetting forces. The LB210 provides accurate and reliable results every time.
Welcome to the Goepel booth here at SMT Connect. I'm joined by Andreas Turk, who's the product manager for the AXI series. Welcome, Andreas.
Yeah, hello, welcome.
So we're looking here at your latest machine. That's the inline 3D, which is fitted with, of course, the multi-angle detector 3. So explain to us a little bit about what that means.
Yeah, it's the fourth stage of this machine, so Series 400. And this new detector, multi-angle detector 3, is a full digital scanning image acquisition detector. That means we can do a 3D scan of the whole PCB or of parts of the PCB in a very short time. So in the past we had flat panel detectors that were mounted on an axis system and moved in the system. And with those detectors you have a nice image quality with those flat panel detectors, but you are low in speed, in 3D speed. So typically per field of view, 3D you take between 3 and 5 seconds. And this is too slow in the automotive industry because they have multi-panel boards, and so you need to be quicker. That's why we developed this multi-angle detector 3. And with this detector, we scan the whole board in a very short time in 3D.
Okay, so instead of using the old step and repeat system from the flat panel, you're using a line scanner, which does it much faster. But how do you do that in 3D?
Yeah, we have multiple scan lines inside, so more than one. And so those multiple scanners acquire different angles at the same time. Let's say if you have, for instance, 5 different detectors inside, 5 line scan detectors, then you can acquire in one shot 5 different angles. Yeah, and this is the secret. And I always say we are some kind of pioneers in the scanning image acquisitions. We do this since 2008, and now with this full digital concept, we are really a step ahead in comparison to the flat panel guys. Let's say.
Well, now AXI is notoriously the slowest part of the inspection process. So, you know, how fast could you process something, say, for example, this board?
Yeah, I have this PCB here. So this size, double side assembled, we do this in 35 seconds, including handling time. And the handling time is also something I want to highlight. So handling time is only 5 seconds because we have a 3-chamber concept inside the machine. So we have 3 independent chambers. And we can provide to you a loading, unloading and inspection in parallel.
Right, so you're basically loading the next board while the first one, the one ahead of it, is being inspected.
Exactly, yeah, that's the point.
So can you show us an example of how fast this machine scans?
Yeah, I can load and test program here easily, so I start the inspection. And the X-ray tube will now switch on and will start. So I show it to you. I say press start, and now you see first a laser checks for the warpage of the board. So those are those red dots. And now we perform the scan. So, and this is not the fastest mode, let's say it's medium speed for a very, very nice image quality, but it's real life. Yeah, and you see here the inspection progress view, and here later on you will see the inspection fail view. And as soon as we have detected some failures, we will highlight them here with red dots. So let's see if the software detects anything. So image acquisition is done. And now you see the red circles here. You did see that? And so it detected failures like on this BGA, for instance, here, and lifted BGA ball. This is easy to see.
Excellent, excellent. And very, very fast, I have to say. So, yeah, that's huge. Okay, so... You can do multiple boards very, very quickly. So moving on onto the actual other parts of the software process, you do AOI and SPI. You also have a system that lets you combine these so that you can, if an operator is really looking at a defect on a pin, he can mine down to see the problem. Can you explain a little bit how that works?
This works with our software concept Pilot Connect. So at the end, Pilot Connect is a huge database that collects the information from SPI, AOI, and AXI. And based on a unique identifier for each pin, we can present the results in one common interface. That means if you have, for instance, an insufficient solder joint, you want to know where does it come from. Right. And you can check at the SPI results, was there something wrong with my solder paste? Or you can check with the AXI image, was there a via that was really getting my solder away from the solder joint. So this is brilliant. It's called Pilot Connect. And the software is also Pilot Verified. That gives you the possibility to classify the failures. Yeah?
Okay. So the industry is obviously moving towards much more factory integration, smart factory analytics and big data. So people are wanting more and more data off the line and measurements, not just measurements of sizes, but volume measurements. How are you able to do that?
Yeah, we do also volume measurements. One example is, for instance, an THT solder joint, or where you check the barrel fill and also the volume for that. And also we can check where a void inside the solder joint is in case of Z direction. And regarding big data, I can tell you over the last 5 years, we did a really nice job there, because we can give you every data that you want to have. Every inspection result. We can also give you some facts about the machine. So how many kilometers did the axis go? How many lifts up and downs did the pneumatic do, and stuff like that. So for the big data guys, we have everything available.
Wonderful. Yeah. Okay. Well, it looks like you're moving forward, and it's a really impressive new machine. Andreas, I want to thank you for showing us it today, and we look forward to seeing the next developments in the future.
Yeah, thank you.